Here we have to find the standard form of the equation, so that means that we have to complete the square on this question. We have x squared plus 4y squared. These are both squared, they're both positive, but they have different coefficients. This one has a 1, the other one has a 4. So this is definitely an ellipse. You want to make sure the x terms are together, and they are. These are both on the same side and they're side by side, and the y terms are also together. The constant should go to the other side, so we'll go ahead and subtract that and move it over there. Here we'll go ahead and group these in parentheses. For y, you want to group it in parentheses because it has a GCF. For x, there's no GCF, so we can just set it up already with a plus blank in order to prepare for completing the square. Here for y, you'll factor out the GCF, the 4 there, and if you take that out, what's left is y squared minus 2y, and then go ahead and put a plus blank here to prepare to complete the square. On the other side, this is still negative 4, but here we introduced a plus blank on the left side, so we have to do that on the right side as well. So I'll put a plus blank that corresponds to that plus blank. For the other term though, this one has a modifier to it. So we didn't have to do this for the blue one, for the x term, but for this one, because there's really a plus 4 outside the parentheses, we have to acknowledge that. We have to put a plus 4, and then in the parentheses we'll have the blank. Technically that's happening here as well with the x. There would have been a plus 1 times the parentheses, so that's why we didn't have to write it for x. Now that we have that, we're going to find the c term. The c term is what goes in the blank. Oh, and also it's not this c term, it's for the trinomial inside the parentheses. You'll find out what b is, divided by 2 and square it, and that will be what goes in the blank. This is an order where we have a, which is the 1 here, b is the 4. So you take the 4 divided by 2, put it in parentheses, square that. You end up with 2 squared, which will be 4. The 4 has to go into both of these blanks. And now you do the other one. This one also has its own c term with the same formula. Here, you just look inside the parentheses. The a is a 1, the b is the negative 2. So that's what goes inside the parentheses. You divide that by 2, close the parentheses, and square this. This will be negative 1 squared. When you square that, that becomes positive 1. That goes into both of these blanks. So we completed the square. Now we're going to factor the left side and simplify the right side. If you want, you can do the right side first. This negative 4 will cancel out with the positive 4. And then all that's left is this 4 times 1. So the right side only has a 4 left. And then over here, this is basically going to be a parenthesis squared, or you can do it in steps like this. But here, this is from x times x. So you take one x and put it there. The other one goes here. After that, you're taking the middle term, the b term, with the sign that it has. So right now it has a plus 4. You divide that by 2, and that would be plus 2. The plus 2 goes into both parentheses. Since it's the same parentheses twice, you can just say it's x plus 2 squared. For the other one, you can do it a similar way. We'll leave the plus 4 on the outside for now. And we can set up either 2 parentheses, or you can do it in one step. Since I showed the 2 parentheses there, I'll show the one step here. We know it's going to be a parentheses squared, and we're keeping the GCF on the outside for now. What you do is basically the same thing. You can think about this as y times y and put one of them here. And then you just take the b term with its sign and divide that by 2. This would be negative 1. So the negative 1 has to go inside the parentheses. I'll write it down here so it all lines up better. And on the other side, we had the 4. Now, this is an ellipse. We identified that at the beginning. So that means that this needs to be a 1 to be in standard form. So if it's not 1, whatever it is, you just divide everything by whatever that number is. So we'll take the 4 and divide it by itself. But you have to do that to everything, since it's an equation. And then on this side, we have x plus 2 squared over 4. Here, the 4's cancel each other out, and this is going to be a 1. Now here, we found the standard form of the equation. I'll put it in a box. So that takes care of this first part. Once you have the standard form of the equation, it's actually more straightforward to find the center. It's based off x minus h squared. In the equation, the y term would be over a 1. So the bigger number, in this case it would be the 4, that's the bigger number in the denominators. That one would be the a squared. So since that 4 would be the a squared, over here, this is a y squared over b squared, and that equals 1. The easiest way to find the center is to line all the pieces up. If you take it from the equation form and put it in the parentheses here, then you flip the signs. Whatever h is, it becomes the opposite sign. The k also gets the opposite sign. So then here where we have the 2, this will flip and it'll become negative 2. And then here where we have negative 1, that sign will also flip and this will become positive 1. So that would be the center. The next thing is to find the major axis, or the axis that it's parallel to. The bigger number is under the x term. That means the major axis will be based on the x, meaning it will be going sideways. So another way to think about it is it's this form of the equation where the a squared is under the x term. So this is one that's horizontal. So the other kind would be this, where you have almost the exact same thing. The numerators are the same, they're both equal to 1, but in the bottom, the denominators would be different. This would be a squared, this would be b squared. This would be the kind that goes up, down. It would be a vertical ellipse. So that's the difference. The bigger number in the denominator determines, or that's how you can tell. It tells you which way.
Okay. That makes sense.
Okay, excellent. Here, this is the case where it's parallel to. The way we know it's parallel to is because if we were to look at the center, because the center isn't on either axis, and instead it'd be right about here, just because it's not on either axis, we know that, and because it goes sideways, we know that it would be parallel to. So if it's being required to specify whether it's on the axis or that it's parallel to the axis, you would say that it's parallel to the x-axis. So that's how you'd answer this. If it was actually on the axis, instead of negative 2, 1, maybe if it was negative 2 and it was over here, this would be on the axis itself, and then you'd pick the option that says the major axis is the x-axis.
Oh, okay.
And so that's the difference. So from the equation, you can also find out what A, B, and C are. So here, I went ahead and kept the 1 underneath the y. For your actual answer with the standard form of the equation, you won't write the 1. But here, I'm going to just point it out that that's a 1. And we know that the 4 there is the a squared. And the b squared is the 1. From this, you can find the square root of both sides. So you find plus or minus the square root of 4. This one turns into an integer, so you go ahead and simplify it, and it turns into a 2. This will tell you how to find the vertices. Remember, A is associated with the vertices. So then what happens here is that you take the center, which was this negative 2, 1, and we're trying to find the vertices. So because this is the kind that goes sideways, you'd be adding the a to the x coordinate. Or let's say it this way, if you think about it as h and k, it's a sideways ellipse. So you'd be adding the a to the h. And so that would be the -2 that's from the center, plus or minus the 2 that we just found, comma 1. And then this, you'd have to split it up because we can get actual integers for the answers. So this would be 0, 1, and this one would be -4, 1. So these would be the vertices. If you had to give them, maybe for a different question, it might come up that you have to give them specifically. And this is how you could do it. It's based off the center. That's why you have to find the center before you can find all of this other information. Now for B, we did have to find the minor points the other day. So what you would do is you just find the square root of this. It would be plus or minus the square root of 1, which would just be plus or minus 1. 1 is its own square root. And this would be the opposite one. So I'll just indicate that these are minor points. By opposite one, I mean, because this is based on the x coordinate, that means for this one, you have to base it on the y coordinate. You still start with the center, but instead of h, you'd be adding it to the other one. So if you added it to h for the vertices, you have to put it to k on this part with the minor points. And so this would be -2, 1 plus or minus 1. And this would give you a good basis to graph as well. You have to split this up where there's a plus version and a minus version. This one would be -2, 2. This one would be -2, 0. So these would be the minor points, and we'd be able to graph these with their specific locations. And then the last thing is to find foci, which in the process of finding the foci, you'd be finding C.
Okay.
When you have a squared and b squared, you use this equation where you have a squared minus b squared equals c squared. And then we know that the a squared is 4, the b squared is 1. So this would end up being 3 equals c squared. I'll flip this around. You find the square root of both sides, so you'd have plus or minus the square root of 3. It's an irrational number, so we'll leave it in its exact form as a radical. This would be enough if you only had to find c, but if you had to find the foci, which you normally do for a lot of the questions, to find the foci, remember this is going in the same direction as the vertices. Or if you don't want to think about it in terms of the vertices and just by itself, the foci will be going in the same direction as the ellipse. Since the ellipse is sideways, primarily going left and right, that means that you'd be modifying the x coordinate. And you still start with the center. The center, you're basically thinking about the x coordinate as the h, and you'd be adding the c to it because it's going sideways, but you leave the k coordinate the same. So you'd say -2 plus or minus the square root of 3, and this one would be a 1. Here, we don't need to split it up. If you wanted to, you could write it twice, with one with a plus sign, the other with a minus sign. But ordinarily, this is enough, because that one, we won't be able to simplify that into an integer, so it's preferred to leave that in exact form.